We've taken a look at our transformations of our functions before, whether we're using our logs, whether we're using our trig functions or just our power functions or parent functions. The general parent function we always started off with is a times f of x minus c plus d. What did the a do to our graphs? What type of transformations?
Vertical compression, subtraction, or
So vertical stretch, compression. What happens if a was negative? About? Absolutely. So if we had that negative for our a, whatever that a is, we had that reflection about the x-axis as well. What about c? What information do we get from there? Shift which way? So horizontal shift. And lastly D. We have a vertical shift. Again, we've seen this before. The vertical, the horizontal shift, reflections, but now we're just applying them here to our exponential. So starting off with our basic parent function, our exponential function. What did that look like? Anyone remember? Some of you have it. That's our nice little exponential function. What is its domain? Negative infinity to positive infinity, all real numbers, absolutely. Its range? Including or not including 0? Absolutely. From 0 to infinity is the range. What about an intercept? Does it have an x-intercept? What about a y? Whereabouts? So 0, 1. Asymptotes? Y equals 0. Our x-axis. Is it continuous? In other words, I take that pencil off the page in order to draw this. It's continuous, right? There's nowhere am I stopping, taking any breaks, so. Increasing, decreasing, constant, mixture of both. Increasing. All right, as we move from our left to our right, my f of x is getting larger and larger, so we're definitely increasing. Riley thinks the answer is yes. Right? Where? Which axis and what's negative?
if A was negative,
Well, this is my y equals a to the x. So if
A is negative, what's
a is negative,
x?
and when I had a negative x, if I have a negative for my a, that's reflecting it about, you guys are right, I would actually have something if I reflected about the y-axis, about the x-axis, it would be a decreasing function, absolutely. But the one that we're looking at, having that same properties of that same intercept and the same asymptote, So everybody was right as far as whether a is negative or x is negative, but we're looking at where x is negative. So it's still going to have the exact same intercept of 0, 1. And in this case, the same asymptote, so they're both above the x-axis. And when would it increase faster? When a is small, large? Absolutely. If I have a large a value, as I increase exponentially, that's going to be very large, increasing much faster. So when it's slower, we're looking at small a values, such as what? Sorry? Why did I say between 1 and 2, not between like 0 and 1? Could those be the small ones? 0 to 1 is a lot smaller, isn't it? We don't really talk about, when we're talking about exponential, we really don't talk about between 0 and 1, because if I have, say, how can I rewrite 1/4? 4 to the negative 1. So this just gives me f of x equals 4 to the x reflected about the y-axis. So it's definitely not going to be something that is increasing at a slow pace or anything like that. That's why when we say, when is it actually slower? Slow one is going to be for when a is between 1 and 2. Okay, make sense, folks? Questions? So let's take a look at transformations. Our transformations, I'm pretty much just concentrating on two things. I'm looking at where that asymptote is, did it move any? And where's my intercept? You do not need to plot additional points. We're just trying to do a sketch of the graph, not plot actual points. So, here we have f of x equals 2 to the x minus 2 plus 3. What do we have going on here, transformation-wise? Of 3?
Right to
So Habib said right 2 units, and Mario said up 3 units. So where originally was my asymptote? Y equals 0. And if all my points went up 3 units, what else went up 3 units? That asymptote. So I now have my asymptote at y equals 3. And we went to the right 2 units. So what did that do to my y-intercept? Where was my y-intercept? It was at 0, 1 right here. So first of all, we know we went up 3 units. That put us at 0, 4. And then we know we are going to the right by 2 units. So my new, if you want to call it intercept, is at 2, 4. So now we just draw that same figure, that same current function that we had with our y equals 2 to the x. And that's all you have to do. You can definitely plot more points if you want to get more fidelity. I'm not asking for that. I just want to see the asymptotes, right? And the intercept, where the intercept moves to. Here we have f of x equals 4 to the negative x minus 4. What type of transformations here? Down 4. Absolutely. So down 4, reflection about the y-axis. So the down 4 did what to us? All right, so at negative 4. Likewise, it took our intercept, which is at 0, 1. It went down 4 units to
0, -3.
0, -3. Yes.
Why is it the y-axis again? Instead of
Why the y-axis? No. Because it's associated with the x. To be a reflection about the x-axis, it would be in the front of the whole function itself. It would be a -4. Then I'd have a reflection about the x-axis. So because it's with the x, reflection about the y-axis, I'm still going to go through that same intercept. But if it's an increasing function, it's now so we come up with that graph. Difficult. Are these functions one-to-one? We talked about one-to-one-ness on Friday. How do we know if it's one-to-one? It passes what test? Horizontal line test, right? Horizontal line test tells me these functions are one-to-one. On Friday, that helped us prove those equations, like when we had a to the x equals a to the y, that implied that x equals y. But what does it also tell us? When a function or graph has one-to-one, it also means it has what? Starts with an I. Then it has an A. Then it has a B. Inverse. Maybe remember that fun stuff. So being one-to-one tells me that a function has an inverse. What is an inverse? How do the two functions compare when they're inverses of each other?
F of negative x.
That's how we would write it. What's opposite?
Sign and the way. X values.
Put those two together. Absolutely. Our x and y values change, right? It's a reflection through the origin, about the origin. So my x's and y's are changing. My domains and ranges are changing between the two. Again, so here, as we look at these exponentials, it passes the one-to-one test. I mean, the horizontal line test, it is one-to-one. It has an inverse. The logarithm function. Logarithm function, if we were to graph this one, this is our graph of our logarithm function. How do I find that domain? It's the inverse to what function? Exponential. What was the range of the exponential? Which is the domain of my log. What was the domain of the exponential? So then the range of my log is? And what was the intercept for my exponential? 1, 0. I mean, it was 0, 1 for the exponential.
Bless you. Bless you. Bless you. Bless you. Bless you. Bless you. Bless you.
So it was 0, 1 for our exponential. So then for my log, the inverse it is 0. Asymptote, before it was the y equals 0. Again, that's the whole idea behind our inverses, right? My domains and ranges, my x's and y's are changing out there. Is it continuous? Of course. Increasing, decreasing? Definitely, as my x goes from the left to the right, y values are getting larger. Does it ever decrease? YouTube says yes. When? When you have a negative. You said it. When I have what? So when I have, say, So I said when I have a negative log, when my a is negative, whatever that value is, negative 1, negative 2. If I had the negative out in the front, that's a reflection about the x-axis, giving ourselves a decreasing function. So just as we did with the exponentials, same thing with the logs. All we're going to do is look at the asymptotes and the intercepts to determine where that transformation is, or what that transformation does. So here we have a very difficult one that has about 6 different transformations. I think f of x equals log x minus 1. What type of transformation do I have? What's happening? Absolutely. We're shifting down 1, vertical shift down 1 unit. Anything else? Does my asymptote change? I don't shift it down 1. Why not? Actually, it's a vertical. It's right there at x equals 0. We're not doing anything at all, so the only thing that will change is my intercept. Where was my intercept? It was at 1, 0, but now we're going down 1, so it now becomes 1, negative 1. So there we have the graph, sketch the graph of our function f of x equals common log of x minus 1. That's what's there. You can if you want. Usually you wouldn't draw it when it's on the x-axis, y-axis. It's always a good thing to put it in there so that you know, and then I know that you know. I know that you know that you know. So here we have f of x equals log base 4 of x plus 3. What type of transformations do we have here? That's 3 units. Anything else? Oh, that's it, folks. The 4 is just your base. All right. Log base 4. So all we have here is a shift to the left by 3 units. So what has moved? So my asymptote, which was at x equals 0, is now where? X equals negative 3. What else moved? My intercept, which is where? Right, it was at 1, 0, so now 3 units to the left. It's now at negative 2, 0, giving us. Yes.
Well, there's no like written base of log. What is it?
Oops, what is that? This is something we're going to be going over more tomorrow. Since this was review, hopefully you guys, some of you know it. It's the common log, folks. Common log has base. Has a common base 10, which we do not. So whenever you do not see that, and again, we're going to go over more of this tomorrow. Right, it's the common log which has base 10. You know, I'll make sure that's just log x. So, questions? A lot of times, though, you want to work the other way as far as here's a graph of the particular function. What is that function's name? What is the equation? So here we have 2 functions. Are they both logs, both exponentials? 1 to 1? What? What's that first one? Exponential. Okay. What about that second? Log? Absolutely. As I always said, just take a look at those asymptotes. So when it tells you, starting off with naming the parent function, we can get transformations. If it doesn't give you one to start with, assume that your a is a 2. So 2 to the x. And likewise, with my log functions, assume assume that you are dealing with a common log, log base 10, unless otherwise stated. You may say, hey, your current function is f of x equals 4 to the x. Describe the transformations. Your f of x is log base 3 of x. Describe the transformations. But if it doesn't tell you what you're starting with, you always assume that you have 2 to the x in the common log of x. So, as Abby indicated, we have those horizontal and vertical asymptotes here telling us that we have our log or our exponentials. So what type of transformations can we see from here? Well, we see the asymptotes no longer at our x-axis, so what happens? And is my exponential normally a decreasing unit, decreasing function? So what else happened? So what is that?
The function across the x-axis.
And that joke said that is telling us that our a is negative. Anything else? We also do have a horizontal shift, but how are we going to determine that horizontal shift?
The intercept?
Absolutely. So where was our intercept for an exponential?
0, 1.
Okay, so it was starting off at 0, 1. We know that we reflected about the x-axis, right? Reflection about the x-axis, we'll now put that point at 0, negative 1, right? We also know that we went, what? Down 2 units. So now that point has moved to 0, negative 3. So now to find out where I shifted to the left or right, what am I looking for? I'm keeping that same value of y equals negative 3, and I'm just trying to associate it with that particular x on that graph. So if we look, we come up to negative 3, negative 3. So this tells me that my intercept went from here to here to over there. So I shifted to the left 3 units. So if you want to think about following the bouncing ball type stuff, right? Start off, where was my intercept? What did I do to? I reflected, I went down or up, and then once you find that y value, right? Say, okay, now where do I see that particular y value on my graph? That tells me how far to the left or to the right we shifted. So, having all this, what is the equation of my function now? What's that?
Why do you start with 2x?
That's what I gave you. You're always going to start off with 2 to the x, unless otherwise stated. Negative for the reflection, actually negative 2. Shifting left 3 units, absolutely, plus 3. Somebody else? So we wind up with our g of x equals negative 2 to the x plus 3 minus 2. Questions? Over here we have our logarithmic function. Some transformations going on here. Again, our asymptote's not at the y-axis anymore. What does that tell me? Shift to the right by 1, absolutely. Shift to the right by 1, my entire asymptote is moved 1 space to the right. Do I have a reflection anywhere? No, there's no reflection about the x or y axis. So now all that matters is how many units did we go up or down? How do I find that? Find that intercept. Again, the intercept for here started at what? 1, 0. And right here we know that we shifted to the right by 1. So that made it go to 2, 0. So now to find out the up or down, We know we're just looking at x equals 2. Finding that value gives us what? Absolutely. So this tells us that we have shifted up by 2 units. Giving us the equation. I'm sorry.
Log of x.
Log of parentheses or no parentheses?
Yes.
Absolutely. We come up with our g of x equals log of x minus 1 plus 3. Questions? Again, unless otherwise stated, always assume that we're dealing with a base 2 for our exponential, or just our common log for dealing with a logarithm function. No questions? You guys want to practice on this? And this, you have more than ample time to finish in class.